I welcome to the limited design of steel structures plus the limited design of steel structure has been introduced in our Indian code in 2007. Before that we used to design the steel structure by the use of working stress method, and from 2007 onwards the codal provision has been changed, and in 2007 the IS 800 2007 has been published, where the entire code has been discussed on the basis of limited design method. Now, coming to this course, actually this today I will discuss about the probable content of the course, which I am going to cover in next 60 lectures, and what are the books you can follow, that I will inform, and what are the code required for learning this course all also will be told today, and also I will show you some steel rolled section, what are their properties, how the parameters are varying, and means how the parameters are considered, which parameters are considered, which are given in the IS handbook, that SP 6, that also I will just give a touch on that. Right. Now, coming to the limited design of steel structure, one thing we can say that nowadays in every city or every country, whenever you see some skyscraper, these are mostly built with the steel. Steel has lot of advantages, which I will come later, and because of its advantageous properties, we the designers prefer for designing the structure with the steel, and steel structures are steels are massively used, particularly in bridge structures and also in transmission tower, refinery oil structure, in sometimes some water tank also are made of steel structure, some high rise buildings, many industrial buildings, sheds, all are made of steel structures. And steel, you know that it is much stronger than compared to the conventional construction material like concrete, compared to its high, strength to weight ratio is very high, means its weight is very less and strength is very high. It is much ductile compared to concrete, and because of its advantageous properties, designer prefers steel structure, though it is costly. So, if we design properly in a cost effective way, the cost can be minimized without compromising the safety. Therefore, we need to know the design procedure properly, and maybe later by knowing the design procedure we can make a computer code, we can generate some computer algorithm by the use of MATLAB or any other standard language like C language, C++, Java, or we can use Excel sheet also. Then in steel design you will see when we are going to design, we have to iterate. We need to iterate the design process, means we will assume certain member with certain dimensions, and we will check certain checks from limit state point of view, from ultimate strength point of view, from serviceability criteria point of view, we will check certain steps, and if we see the checks are not satisfying, then we have to increase the size, and if we see it is satisfied, then we can go for this particular section. But what happens that while we go for iteration, in case of limited design, there are a lot of procedures, means procedural calculations are there. So, it is very difficult to do by hand, manual calculation. So, if you can develop a computer algorithm, or if you can develop an Excel sheet, then just by putting the value you can check whether it is okay or not. And in some cases we have seen that when designer is saying that the assumed section is okay, then they are simply going with that section, but that is not economic, because maybe with some lesser section the same with same loading it may be safe. So, we must go for the lesser section. So, sometimes designer does not want, because a lot of calculations have to be done, it is a tedious process. So, I will suggest you that if you know the design algorithm, if you understand the design process of a particular member, then you make a customized program at your own requirement and then go for the this program for design of the section, and in that way you can make the design optimized, economic and cost effective. Now, coming to the anatomy of the structure, we will see that any steel structures are having this type of members, like one is beam. Beam is basically a flexural member, where the flexural actions come into picture. So, we need to know the design of a flexural member of the beam. Then it will come the column. Column also takes basically the compressive load, along with that certain eccentric load also it takes care. So, sometimes moment also come into picture, that column has to be designed accordingly. So, we will go through that column. Floor basically carries the load and that load is transferred to the beam and column. Then bracing system is an important system in case of steel structure, because you see here, if we see, these are the bracings. Bracings has been provided just to increase the load carrying capacity in terms of horizontal load. When horizontal load is more, then we can provide certain bracing in certain places, so that the system became stronger. Now, all the superstructure load are going to the foundation. So, we need to know the foundation design also. So, there in foundation we will see the slab base, gusset base, base plate, and how the load from the superstructure has been transferred to the substructure by the use of base plate and other members, that we will see. And another important part which we do not generally come across in case of RC structure, that is connection. These connections is important in the sense we know the rolled steel sections are available, or some other type of sections also can be made available in terms of built up sections, etc., but it need to be joined properly. So, join means basically joining of beam and column, beam and column. When you are going to join, you have to join either by the use of bolt, rivet or weld connection. So, in fact, when I will be going to teach this subject, so first I will discuss about the connection, because if we know connection, then we can go the further things. And in design, means in steel design as a whole, connection plays a very important role. We do not give much importance to the connection though, but we have to make detailing, means I would recommend that when we are going to design a entire system, we have to specially look for the connections, and we have to design connections properly, so that load is transferred from one system to another system, one member to another member properly. Sometimes moment also has to be transferred, sometimes only axial force. So, on the basis of the requirement, we have to decide what type of connections we will be going for. So, syllabus which I am going to cover, I am briefly discussing, but it is a tentative, because I do not know how much time I will get to finish. First module will be including the introduction, and which will discuss about the steel member, means steel material as a structural material, and we will discuss its advantages and disadvantages of the steel, because unless we know the disadvantages of steel, we will not make use properly. So, we must know the advantages and disadvantages, and accordingly we should try to use that. Then we will go for different type of sections, IS rolled sections which are available in the market, those and their properties are given in the code, that we will see. Then we will go for some material overview, means how the steel behaves with increase of load, means how stress strain varies in case of steel, and how the chemical properties how chemical properties means how the mechanical properties are dependent on chemical properties of the steel, that we will discuss. Then basis for structural design will be discussed, means what type of structural design we are going for in this course, that we will discuss, that is the limit state method, and what are the basis of design of that structural philosophy, that will be discussed. And of course, loading and load combination, different type of loads come into picture, those will be discussed briefly and their combinations. Then we will come to the module 2, which is comprising of connections. So, different type of connections we will discuss, and in that connection we will discuss about the bolted connections, its advantages and disadvantages, then design of bolted connections, its efficiency and design of joints, then welded connections, advantages and disadvantages of welded joints, design of weld connections, fillet weld, butt or group weld, plug and slot weld. So, these are the topics, probable topics I am going to cover. Then in next module we will discuss about the eccentric connections, because sometimes connections become eccentric in terms of its loading. So, different type of eccentric connections are observed. So, we will discuss about that. Then bolt and welded connection with load lying in plane of joint and load lying perpendicular to the plane of joint. Different type, means two type of eccentric connections are observed. One is load lying in plane of joint and load lying perpendicular to the plane of joint. Then we will discuss about the design of eccentric connection using bolts and weld. That means, sometimes we will use bolt, and we will see how the design procedure is proposed, and also same thing for weld connections. And in module 4 we will discuss about the design of tension members. In tension member we will first come into different type of failures, mean in case of tension member what are the failures occurs, that we will see. Then we will find out the gross and net sectional area, then rupture of critical section, then strength calculation, block shear failure, then slenderness ratio of the member, and then we will come to design of tension member concerning all this, and then gusset plates, lug angles, tension splices, design of tension member subjected to axial and bending, those things will be discussed. So, tension member will means in this module we will cover these aspects. In module 5 we will discuss about the compression member. In compression member, first we will see what are the type of failure occurs in case of compression member, and accordingly the strength calculation we will discuss, and then slenderness ratio of the compression member, how to calculate we will find out, and then design of the compression member, and then design of eccentrically loaded compression member. That means, when moment also will come into picture, then how to design the compression member, that will be discussed. Then built up compression member, means sometimes the rolled steel section is not sufficient for withstanding the huge amount of load. So, in that case we will go for built up compression member, and that design procedure also will be discussed for the built up compression member. Then for built up compression member we need to add the lacing system. So, design of lacing system and design of batten plates will also be discussed in this module. And in module 6 we will discuss about the flexural member, which is called basically beam. So, we will give some introduction to flexural member, and then design procedure of beam, and beam will be basically two types. One is design of laterally supported beam and laterally unsupported beam. So, both the cases design procedure will be discussed considering laterally supported and laterally unsupported beam, and also will be discussed about the built up beam.